Namaste students. Today's concept is computational thinking, grade 6, chapter 2, lines and angles, part 2. What will come in place of question mark? As we have clocks, let us first read the time. Okay, here they have given you angle, measure of angle. So here it is two numbers, obviously it's going to be 60 degree. Here it is three numbers, it's 90 degree, and we have 60 here. So I guess the smallest angle in this case again 30 30 30 30 30, so it's gonna be 150, and here it's gonna be 30 30 30 90. Oh great, so the smallest minimum angle. But here I see it's a straight line 180 degree, and here straight line is 180 minus 30, which is 150, but here we have 120 degree. Great, so that is not the concept. Let's check if there is any other possibilities. Great, I found it. Here you have 9, starting with 9, it's ending at 11. Here we have 9, ending at 12. So when you overlap this, it's 11. So they are checking with the common angles, I guess, 60 degree. Here it's the same. It's starting at 4 and 1. It's 4 and 1. So the overlapping part is 90 degree. On the other end, here it is 180. Okay, wait. It is at 6. The second clock, the hand is at 6, one of the hand, and the other one is at 11. So the overlap part is 30, 30, 30, 30. 4 into 30, it's 120. Great. Coming to the next one, 11 and 4. So the overlapping parts are like two readings, that is 2 to 3 and 3 to 4, which is 60. I go with option B. Okay, let's check once again. It's 4. On the other side it is 11. So the overlapping part is 2 to 4, which is 60. I go with option B. Moving to the next question. How many times in a day on a 12-hour format clock do the minute and hour hands form a straight line, an angle of 180 degree? Let's consider a clock, and we know that there are three hands: minute, hour, second. Great. But the question is how many times it makes 180 degree. So let me check one working clock here. Great. Now it's 12 o'clock. As you see, 12 a.m. Let's check how many times it makes 180 degree. Here we go. Move this. Okay, I'm moving minute hand. Still not 180. Yeah, now it's 180 at 12:33. First 180 at 12:33. The second is at 138. Okay, here we have third one. And let's move. Here we have fourth one at 3:49. And fifth one is at 4:54. Sixth one is at 6 o'clock. Great. Seventh one is 7:05. Eighth one is 8:10 approximately. And ninth one is at 9:16. 10th one is at 10:22. And the 11th one is at 11:26 or 27 approximately. Okay, great. Stop. So now it is 12:33 p.m. It is after 12 hours, I guess, isn't it? We started at 12:33 and it's come again to 12:33. So I believe you would have counted. So it's 11 times from 12 a.m. to 12 p.m. It is 11 times. Then from 12 p.m. to 12 a.m., it's going to be another 11 times. So in a day which is 24 hours, there will be 20 to 180 degree. I go with option C. Hope you agree with me. Moving to the next question. In the given figure, triangle 2 is a right angle triangle. Both triangles are arranged such that the red circles completely overlap, meaning both the triangles meet at point P. Great. Triangles cannot be rotated, okay, or flipped. If an angle 30 degree is formed between triangle 1 and 2, okay, let's imagine, visualize the same. Here I have one triangle, get the other triangle, let them overlap. Okay, and according to the question, the angle between these two is 30 degree, and one of them is a right angle triangle. So the angle between these two, that is APD, is obviously 120 degree. Let's move on to the next question. Sam draws three line segments AB, BC, CD. Factorize the same. Here I have one ray AB. Let us assume this is BC. This is AB and this is C. Oh, wait a minute. Since B is common, as you see, B is common, let's write this is BA and this is BC. An angle between them is 108 degree. Okay. On the other side, I have D, CBD, where the angle is 162 degree. And you know what? Obviously, this will be 90 degree. As we know, the complete angle is 360 degree. In that will minus 108 degree, another 162 degree. So the remaining angle is obviously 90. Okay. So hope you understood that. Yeah, that's not in the question, but I just wanted to make sure that this angle, it's going to be 90 degree. Okay, let's read the rest of the question. These angles lie on either side of the line segment BC. Later, he draws a pair of parallel line segments. Okay, he draws pair of parallel line segments EF and GH, both perpendicularly intersecting BD. I believe this is B, this is D. Let's draw two perpendicular lines. 1, 2. First one, name it as EF. The second one, let's name it as GH. Okay, I'm done with it. Now, what have they asked is how many pairs of parallel line segments appear on the sheet? Okay, it takes time to understand the question, but the answer is simple. How many parallel lines? Obviously, this is parallel to this because this is 90 degree. The EF line is perpendicular. Perpendicular is 90 degree. And the other one is also perpendicular 90 degree. So this is A actually. Line BA or the ray BA is parallel to EF. And again, EF is obviously parallel to GH because both are perpendicular given in the question. Then BA is parallel to GH according to axiom. If this is true, then option C. There are three pairs of parallel lines. Three pairs of parallel lines. Let's move on to the next question. My favorite. A line segment AB is shown below. 5 points C, D, E, F, G lie on the same line segment AB such that all the points are at equal intervals. The length of segment CB is equal to the length of GD. Wait a minute. Length of CB is equals to GD. So let me say CB, GD, 1 unit, 1 unit. Or you can also write it as CB, GD, 2 units. And here I have 2 units. Okay, it can be 1 unit or 2 unit. Let's fix for 2 units for now. They may ask which is the longest, something like that. Okay. Okay, let me erase this for now then. The first condition is done, I guess. Oh no, the second condition is done. The length of segment CB so and so. Point E, point E is immediately to the right of the C. Oh, great. See, I expected there will be a twist. Point E is towards right. So let's put it here. Done. Okay, what's the next point? We are done with first point, second point, third point. The fourth point is point F cannot be next to E or D. The only option is F to be here, but it should not be next to D. So this arrangement is wrong. Great twist, isn't it? Oh, wait a minute. In that case, let us do this. Let's take the C, put it here. Let's take this G, put it here, and I fix F over here. Okay, so F is not next to D or G. I mean D or E. Yeah, X is not next to E or D. Great. Now let's check the distance between CB and DG. It's not gonna be okay. This is 1, 2, 3, 4 units. CB is of 4 units, but GD is of 1 unit. Let's rearrange once again. Okay, in that case, is that okay? We'll rearrange it. I put C here. Immediately to the C is E and GD. It's not happening. Let's take C here, G here, D here, and E here. Now it's all good, I guess. So 1, 2, 3 units from G to D. 1, 2, 3 units. Great. The final question. The final question is, what's the final question? The final question is, which segment among the following option is longest? Obviously, it's A to B, but it's not given. Okay, let's check what are the options here. G, C, no. F to E, okay, maybe. G, E, no. F to D, yes. I go with F to D. Great students, meet you in the next session with next set of questions. Thank you.